need to do that. We need to do that. We can push that back this way here. Right there. So I think the cord I have for my my microphone might have a short in it. So that's what's going on there. All right, so we're back here. We're doing Jan 2019 first. Okay, so those online, right? Let me actually put the Jair. Jair is here, right? And then Noah just logged on too. Right, okay. So we're not seeing Zian and Janaya, but everybody else accounted for either absent or present. Okay, good. Lovely. Right. Folks, good evening. Thanks for your patience and sorry about the wait. What is our ready to start something? I feel I have a short in this code here, so they might keep dropping out. Okay, I have the rest of the stuff printed for you all, so we don't have to wait on those, but yeah, we already kind of half an hour late, that's my bad. But thank you for your patience, right? Okay, so those in class have had some time with this question, those online would now kind of be seeing it, right? So let's take a bit of a read, and then we'll go from there, shall we? Right, diagram below, not drawn to scale, shows a circle. The importance of not drawn to scale means you cannot take your protractor and measure these angles. It's not going to work, all right? The points P, Q, R, T, and V are on the circumference. P, Q, R, T, and V are on the circumference, right? Now this shape inside here looking kind of weird, right? It's looking like a kind of five-sided thing, but let me show you a little trick here, right? If just for a second you ignored this line and this line, are you seeing the cyclic, let me take a second. And this line here, are you seeing a cyclic quadrilateral? Yes. It's a trapezium, right? Okay, cool. So we have one of them, right? And by the same token, if you were to ignore this line and this line, could you see the other cyclic quadrilateral? All right, cool. Now, it says QRS is a straight line. QRS is a straight line. It's not a tangent. So sorry, the question you were asking me, that's not a tangent. And a tangent touches a circle at one point. It doesn't go through the circle, right? This is what you call a secant line, S-E-C-A-N-T, all right? There's actually a rule with a secant line, but you all don't have to know it. It's actually pretty cool. Anyhow, so angle PVR is 75 degrees, and TRS is 60 degrees. Determine the value of each of the following angles, showing detailed working when necessary, and give a reason to support your answer. So the first one they want is PTR. So PTR. That's this angle here. So I heard you say it. So let's just give those who may not have had a second a chance to try it a minute, right? So let's just call it angle A, right? So we'll call that A. So everybody's scrappy writing below there. Let's put this in a slightly brighter color. TPQ. TPQ is this whole angle here. Let's call that angle B. And the obtuse angle POR, hold on one second, where O is the center of the circle. So we had to draw a center of the circle, O, and we had to draw a line from P to O, and then from O to R. Yep. And the obtuse angle is this angle here. Right? What we call last year? I didn't put any marks, sorry, but most likely they would have each been 2 marks. Maximum 3. I don't think I'd have gotten more than that. Hey, thanks for the likes, TikTok. I appreciate it. Acoustic, VVC, and Math 3XZ. Right. Do you have a different TikTok page for accounts? No, it's just one page. But I had accounts earlier from 4 to 6. You kind of missed that one. But my YouTube channel have plenty of accounts content. Right. If you need any specific topics or whatever, let me know. No? All right. Right. Okay. Cool. So we'll give Aisha, D'Angelo, Jair, Michael, and Noah a minute or two to try the question. Maya Steele. How are you doing, Maya? How are you doing? Evening. So what we'll do is let me scroll along a little bit, and I'll copy and paste this page. Let's go back here. Right, so what we'll do is we'll take out some of the extra stuff here so we could focus on one thing at a time, right? So if we zoom in here, right? So anybody, what was the value of angle A? Anybody? 75. right? And what's the reason for 75? In the same segment, standing on the same arc, right? Yeah, let me yeah, so if we were to block out this line here and this line here, can we see the kind of butterfly rule there? Right? The kind of double triangle thing. So what does it say? Well, I say the angles up in the corners are equal, and the angles down in these corners will be equal as well. All right. So the correct note, what do you call it? The correct articulation of this rule is that the angles in the same segment standing on the same arc are equal, right? So if we scroll down a bit, we could put A is, okay, hold on, I need to zoom out, sorry, yeah. Because it's not letting me, yeah. So that's equal to 75 degrees. So angles in the same segment. Standing on the same arc are equal. All right, I just put some dots to save some time, okay? Hey, Bunny, good evening, good to see you on. Love Zaria, how you doing? Maya, how you doing? Right. Is this considered as measurements? It could be, yes. I would probably more classify it as geometry or circle theorem though. But I think measurement might more be in the realm of things like area, perimeter, volume, that sort of stuff, which this is not, so it may not be considered measurements. But I'm not sure what syllabus you're talking about, so it's quite possible that it could be. All right, but I would need to see the syllabus first to be sure. Right. Okay. Let's go to the second page here, and we'll scroll. We'll zoom in here. All right. We'll replace this with 75. We'll take out this angle here. Right. So what we're looking for now is the green one, right? Looking for angle B. Right, so if we block out some lines here, right? Give yourself. Right, if we block that out, can we see the cyclic quadrilateral? And there's a rule that says that, sorry. Okay, cool. Right, so this angle here is the exterior angle to a cyclic quadrilateral. And the rule says that it is equal to the opposite interior angle. So for here, the answer for B would simply be that it is 60 degrees. All right, and the rule is that the exterior angle of a cyclic quadrilateral right is equal to the opposite interior angle. All right. Hey, Cupid and the great Shane. Thank you for sharing the great Shane. Appreciate it. Suzanne, good evening. All right. Hey, Asha. What vibes? Okay, right. So the exterior angle of a cyclic quadrilateral. Now, if you want a little more detail there, let me see if I can help you out, right? Now, would you agree that, now they did tell us up here that QRS is a what? A straight line. So that's this line here, right? QRS. And what is the angle on a straight line? Aha. So if we consider that the whole angle is 180, what would the purple piece be? 120, because 180 minus 60 will give us 120 on the inside here, right? And these are opposite angles of a cyclic quadrilateral, which are supplementary. They add up to 180. So if this piece is 120, to find B, you'd have to subtract 120 from 180. And that will give us back the same 60 on the outside. All right? Okay. The last thing we had to find here, so I'll take out this piece here. I'll put this back as 75. Actually, no, I'll leave that. So we had to find angle C. So let me blank out something here, right? Now, you could either blank out that side of it, Right. So you mightn't recognize this right off the bat, but it is, in fact, sorry, this rule here. It is this rule, it's just that the top here is kind of skewed to one side. So imagine if I drew the line this way and then duck it down so. Right? And take out that. Yeah? Right. So this is the rule that the angle at the center is equal to double the angle at the, at the circumference. Mix the Sherika, what are you doing? Huh? Yeah. Right? So the angle C would be equal to 75 by 2, which is equal to 150 degrees. So, right, so for this one here, right, obtuse angle is equal to 75 by 2, which is 150 degrees. Sorry for the writing, my bad. And this is because the angle at the center of the circle sorry about this crap writing, is double the angle at the angle at circumference. The angle at the circumference. Yeah, let's not even idea. Okay, right. So I put each reason on a different page, so that way I find doing that kind of lessens the clutter on the page. So like when I send it now, it's a bit easier to read than something like maybe this. So actually, well, this was also done separately. Anyhow, right, whatever. That actually wasn't bad. That wasn't bad. This wasn't bad. This was so much. Anyhow, sorry, we're here. Right. Okay. In class, people, are we okay with 2019 Jan, all three parts? Yeah. Go ahead. Right. Right. So the 75-degree angle would be this angle on top of here.
Oh.
Yeah. All right. No problems. All right. Google Meet. So Aisha, D'Angelo, Jerry, Mikhail, Noah. If you guys are good with all three parts, give me a Genie chat. If you need me to re-explain any of them, all of them, give me a R. Right. And give me which letter it was, A, B, or C. All right. Cool. Thank you. Part B. Okay, no problem. Let's go to part B. Right. So what I was saying here for part B, Jair, is that we have a cyclic quadrilateral, right? We have a four-sided shape drawn inside of a circle, such that all four of its vertices are touching the circumference, right? So that is what qualifies it to be a cyclic quadrilateral. And then what happened is they extended or produced QR past the circumference of the circle. So they call it producing one of the sides, right, from R to S. So this here, they told us is a straight line. And we know that the angle on a straight line is 180 degrees. Now, they also gave us that this portion outside was 60 degrees. So we know if the whole angle is, sorry. Okay, that's now, sorry, yeah. If the whole angle is 180 degrees, and we know this is 60, we could find that this piece here is 120 by doing 180 minus 60. So let's give them a quick G if you're good with that particular part, Jerry. That we found, how we found the one, right, good. And now, the rule with cyclic quadrilaterals is that the opposite angles are supplementary, which means that they add to 180 degrees. So it means that right? It means that B plus 120 is equal to 180. So therefore, to find the value of B, we'd have to subtract 120 from both sides of the equation, which will give us 60 degrees. Right? So that's how we would find that. Now, again, the shorter way to do it is, like I was saying, we had a bit of an addendum to the circle, this rule for a cyclic quadrilateral, right? It said that the exterior angle, if we produce a side of a cyclic quad past the circumference, we extend that side, the angle on the outside, right, is equal to the opposite interior angle. right? So here, this is the angle between the produced side of the cyclic quadrilateral, and it is equal to the opposite interior angle, right? 60 degrees. So whichever way you chose to do it, you get the same answer. All right, so just give me a G again. Jair, if you're good with it now, overall. Please answer. All right, cool. GT, all right, lovely. Okay, so let's go to 2018 May. So I have the hard copy here from in-class people. So let's walk around and what you call it, distribute it. Those online, you could always take a screenshot or have you if you want. Okay, so I'll give you a minute or two to just walk through it and see if you can make sense of it. Right? Because I don't want to do too much work for you all. Right. Daya and Chu, how you doing? Cosmo evening, what's up? Right, so I'm also just going to copy and paste this page a few times. So because there are three angles they want you to find, right? ABC. Right, so ABC would be this angle here, right? I guess we could call that angle A. Right, and then they want CMB. CMB would be this whole angle here. We'll call that angle B. Why not? The last one is NMC or NCM? NCM? Sorry. Okay, cool. NCM. NCM will be this angle here. Yeah, we could just call that angle C, right? Okay, cool. All right, so I'll go back here. Let me just zoom in for a second so we could see things a bit more clearly, right? And let's take a little preliminary read. Oh, lovely. Sorry, who's that? Oh, hey, Michaela, Dasa, Samesh, and Tish Tish. I go to him. Yeah. USTT. Hey, Carrie, all right. Right, the diagram below not drawn to scale. So again, they have to explicitly say not drawn to scale, so that way you know you can't take your protractor and measure the angles to get the values. It wouldn't work. Shows a circle with center O. So they tell us center O. Now, what do we observe passing through center O? We have a straight line through center O from one point on the circumference to another. What do we call such a line in a circle? A diameter, which cuts a circle in half. Half a circle is a semicircle, and the angle in a semicircle is 90 degrees. Right? So if we build a triangle on that diameter, the angle opposite the diameter is 90 degrees. So this angle here would actually be 90 degrees. Okay, points A, B, C, and M are on the circumference. A, B, C, and M are on the circumference. Now, check this, right? If you were to blank out this line here, do we see a cyclic quadrilateral? Yeah, all right, cool. Oh, no, we'll jump out. Right. I hope he comes back soon. Oh, two people? Oh, okay, well, hope they come back soon. Right, so we have a cyclic quadrilateral. And what do we know about the opposite angles of a cyclic quad? Yeah, supplementary. Now, the opposite angle to this 58 angle is this angle here, not so? And that's one of the angles we have to find. So that one we could find pretty easily. All right. All right. Now, we're still reading through and analyzing some stuff here. We're not done. Right? The straight line CN is a tangent to the circle at point C. So this line here is a tangent to the circle at point C. Right, now we don't have any radii touching that tangent. Now OA is a radius, OB is a radius, but neither of those touch the tangent, right? Okay, but we do have two chords. We have AC and CM, and we know that the angle between tangent and chord is equal to the angle in the alternate segment. So we have that, and then this one here would be equal. What was the alternate segment? That would be across here. All right, interesting, and this is a chord too, right? So if we took tangent and chord, that would be 58. All right. Okay. Right. This is a chord, yes? Okay. This is a tangent, yes? So if we consider the angle between tangent and chord, right? You see the angle there? Right? That's equal to the angle in the alternate segment. Right? Let's blank out some lines so we can see it a bit more clearly, right? We blank out this line and then blank out this line here. Does that help? Yeah? All right. Sorry? Right, okay. Yeah. Uh-huh. Okay. Which one? The green one? Which line? Right, so hold on. So this angle here is 58. I could agree with that. Uh-huh. All right, this one. Let me blank out some lines here. You mean this piece here?
Those two curves it's making two segments, so that's what's confusing.
Okay. Oh, this one here? Okay. Yeah, no props. All right, cool. Sorry, and then the straight line CN is a tangent to the circle and and then is perpendicular to BN. Okay, so look, they're telling us that there's a right angle down here. So there's a 90-degree angle there. All right. Okay. All right, so so on this page, let's talk about angle A on this page, right? So if we blank out, let's blank out a couple of lines, all right? We blank out, hold on, let me see if I can just go down one right. If we blank out this line, and we blank out this line here. Whoops. Right, so do we see the triangle? The right angle triangle, yes? All right, cool. And the angle there is 90 degrees as we just said, right? And we have a 58-degree angle. So how do we find A? Correct, because the sum of the angles in a triangle is 180 degrees. Page. You okay? You're looking a little. All right. Well, try as much as you can try. All right. So this is equal to 180 degrees minus 90. Sorry. 90 degrees plus the 58 degrees, right? So 90 and 58 is 148. 148 from 180 is 32 degrees. Right, so we have a couple of things to notate here, right? The 90-degree angle is because it's the angle in a semicircle. Okay, cool. And the 180 is because angles in a triangle add up to 180 degrees. All right. Okay. Are we okay with that one? All right. Google Meet, just give me a quick G. I know it's an easiest one, but I want to make sure. Just give me a quick G in the chat if you're good with that one. And we'll go on to the next part, right? Of course, if you need me to re-explain, that's not a problem. Just give me a quick R for re-explain. All right, that was very cool. In class, people, we okay with our first one? Any questions? Anybody? Anything? Yeah? You okay? Okay, cool. All right. All right, so in this one here now, we're looking for angle B. So we said one thing we could do here is simply, hold on. Actually, let me, yeah, hold on. Right. If we blank out this line here, are we seeing the cyclic quadrilateral? Let's also blank out the tangent. And let's blank out that piece there. Cool. All right, so are we seeing the cyclic quadrilateral? Yes. And what is the rule about the opposite angles of a cyclic quadrilateral? They are supplementary. So if we know the angle of 58 and we know B is opposite to it in a cyclic quadrilateral, how would we find B? Correct. So 180 minus 58 is 122. Right. So this is because, oops, that's a very weird thing to do. Right? So opposite angles of a cyclic quad. And please do endeavor to write neater than I do, or more neatly, right? Supplementary. All right, cool. So in class, people, are we okay with angle B? You all right? I see you kind of standing there. Hey, Prajesh, how you doing? Processing, all right, no problem. Google Meet, you know the drill. If you guys go with angle B, just give me a quick Genie chat, please, and thanks. Right? Now, if I'm moving too fast, right, type a F, and I'll give you more time. All right. Yeah, no problems. Hey, Sydney, evening, how you doing? Good to see you out tonight. All right. All right. And the last one we have here is angle, what you call it? Oh, just now. One sec. Yeah. Oh, sorry. Here. No problem. Hold on. Yeah, no problems. No, sorry, I commented on somebody's post on TikTok and it turned into a whole thing. So the lady was complaining about how long circular mall is neither long nor circular. All right. So I just commented. What was I commented on? Oh, Mon Coco Road. They start like somewhere where Maraval and Paramin meet, and end up by Westmoreland's. Right. It's past over the hill, through Pity Valley. It's cross four roads. Somehow cross four roads, right? The Go Martin Highway, right? And end up going down in there by St. Finbarr's, by St. Anthony's Church, by Dunross, and end up on the Western Main Road, right? So like, how? Yeah, where? Anyhow, so I commented, and then somebody else say, what annoys them is how Maraval Road is not in Maraval. It's not even near to Maraval. But apparently somebody was saying on a map, she said that Maraval Road extends onto the savannah, passes the Whitehall, and enters the roundabout.
You know, I called the police for something when I used to live in Maraval. And I said, in Maraval. And they're like, that's not Maraval, that's Santa Cruz. And I was in the middle of Maraval.
Santa Cruz? Anyhow, sorry, you getting sidetracked, my bad. Yeah. No, you really had to watch the EBC boundaries, eh?
No, I watched it though.
Anyhow.
Because no, when the police person came, I asked them, I was like, is this Maraval? He was like, yeah. I was like,
Some people just call
this
by
Santa
Motor
Cruz.
Santa Cruz, but Saddle Road, same thing.
And Saddle Road is started by KFC Maraval and end up somewhere in Sawa. And it's pastoral kind of place. You understand? Anyhow, but all them roads is pastoral kind of thing, pass over highway through hill. But Mokarapa Road ends by a traffic light, and right after is Warren Street, and that ends by Rosalino and you have Roberts.
From Saddle Road region, quite crazy.
Yeah, exactly.
I don't understand.
Or I shouldn't say the crazy. Anyhow, let me go here. When you spell quiz, it's CROISE accent acute and E again, right?
You know
Anyhow.
what I didn't have to spell it?
Really? You know, they say crazy, but it's supposed to be pronounced.
No. If you think of croissant, right? CROIS. So croissant. but because of the broken French here. Anyhow, sorry, let me get back here. So, folks, do you notice that this blue angle is actually kind of ensconced in a right angle triangle? Right. And what do we know about some of the angles in a right angle triangle? They add up to 180 degrees. So if we already have a 90-degree angle there, right? If we could find the value of this angle, we could add it to 90 and then subtract from 180. So here's my question. Can we find that purple angle? What other angles did we find previously? Let's fill in some blanks here. We have a 90-degree angle here, not so? The angle on top here was 32. And what was the angle we just found? This angle here, not so? 122? Aha! And is that straight line, not so? Or what's the angle on a straight line? 180 degrees. So if we have the green portion of it, how do we find the purple one? Subtract from 180. And when you find that angle, in pounds or kilograms? This is weight.
It just come up on his spot. She said weight, he said pounds or kilograms.
I put on the same comment. The same lady who responded on Marava wrote, I put weight, in pounds and kilograms. So, yeah. Yeah. If you look on a map, Marava Road ends right after the roundabout by the zoo. Savannah has different roads combined. It's kind of complicated. Oh. Yeah. Well.
Is there anything to do with the fact that A is 58 and M also in the main 58? Is there a route to
Which one ends up being 58?
M?
Oh.
M and A.
That's a good question. Hold on. Actually, yeah. Yeah, no, right. Remember the rule we were talking about earlier in the addendum thing, the exterior angle of a cyclic quadrilateral is equal to the opposite interior? Yeah, that's it. These two angles are opposite angles in a cyclic quadrilateral, right? And this is an extension hold on. And this orange piece is an extension of this side of the cyclic quad, not so? Right, so the rule applies. Wow, okay. So we ain't matter work out a whole set of thing. We could just say, hey, that angle is 58. Right, but remember, we're not looking for that angle, eh? We're looking for the blue one.
I messaged Chris more than I messaged Melanie. Basically, I see Chris more than I see my dad.
Right, so that's equal to, we'll do 180 minus 90 plus 58. 90 and 58 is 148. 148 from 180 is 32 degrees. So that somehow managed to be equal to that angle on top there. I wonder if... Wait, but those two triangles therefore are similar. That's interesting. Maybe, I wonder, boy. How... That is interesting. Right, so 180 is because angles in a triangle sum to 180. The 90 was given and the 58 was at the exterior angle of a cyclic chord dot dot dot, right? We won't put the whole thing because we put it already a bit earlier. And when you're tired, things just get real strange. It's alright. We understand. Google Meet, just give me a quick G if you're good with what on the screen currently. If you need me to Google it again, just give me a R. It's not a problem. I just want to make sure we on the same page. Hey, Gabe, what's going on, boy? That's you. You're changing your handle. Alright, nice little fancy writing. Alright, so that's Mikel, D'Angelo, Jerry, Robert, Aisha. Aisha, we on board with that? Yeah, man, Gabe, what vibes? You good? Elia, what vibes? So, Gabe, I was getting confused. How come I can see it there, but you're not on the online view? Yo, okay. Let me ask. Google Meet page wants to know what I could hear when she's singing Shimmy Shimmy Cocoa Puffs. Michael, D'Angelo, Jair. Anybody else? Oh, you good? Oh, yeah, man. Genie shot. If you're good. Alright, cool. Now, Michael says nah. He's not hearing page singing. Alright, cool. Alright. We okay with that one? Alright. In class, people, you okay with this one here? Lovely, right. So that's the 2018 May. So we're hitting 2018 Jan.
Yay!
Good one for your money here.
Oh, Chris.
Yo.
I don't. I'm happy. I'm happy. I need to. Can I send you that?
You don't want to send me to you, but you send me this.
The list, yeah, that's what I mean. Add it again. Just let me know. I'll help.
Print them, yeah?
Well, can you find them for me and send them to me so I can print them?
Yeah, I can give you access to the world. So, wait, you have them for homework for when?
Yeah. Jan, June 2021, 2022,
Yeah, that's
he was trying to give us 2020, but I told him after.
Well, they're off for 4 weeks from school, technically. So 2 papers a week, yeah, I can see that. A paper every 3 days.
I just watched him, I was like,
And Sundays off, yeah.
I was like, sir, because I call him Mr. Manzanilla, right?
Mr. Manzanilla.
But I call him Mr. Manzanilla. I was like, sir, you were unserious.
There was another Mr. with an M who used to teach maths or add maths something, I think. No, there was another one. There was another one, but I think he left. Manrakan.
Yeah. He left like
Isaiah, Evie, Heavy, Clara, Cello, what about Cello? Reese, what's going on? Alright, folks, there we take a little zoom here. Hold on, how many angles are we find this one going? Right, just now. It's 4. Alright, hold on. So let me put 4 copies of this one time. Well, 3 copies, I should say. I don't know how real work to clear this up. Anyhow, I done do it already. So, all right, let's take a little read here, shall we? Diagram below, not drawn to scale, shows a circle with center O. So we have center O, right? The points A, B, C, and so the letter B was cut off, right? But I mean, I think we could guess that it was B. What would be this? Show vibes. Right. The points A, B, C, and D on the circumference of the circle. So we have A, B, C, and D, and we could kind of see a cyclic coordinate, so. All right. EAF, and EDG are tangents to the 2 tangents to the same circle, boy. All right, at A and D respectively. AOD is 114. That's 114 there at the center of the circle, and CDG is 18 degrees. So that's between a tangent and a chord. All right. So they want us to find a few things. So ACD is the first one, but first things first. Let me take a look here. Let me just identify some things first. Right. Now, you're correct. Check it. OA and OD are, a radii in the same circle, right? Which means this triangle here would have to be an isosceles triangle because all radii in a given circle are equal in length. And if you build a triangle using two radii and a chord, right, you have an isosceles. Now, we also have this rule here. Look at it. We have this rule that the angle at center is double the angle at circumference. So that would help us to find part A, right? Because this is the angle at center and this is the angle at circumference. Right? Now we also have a cyclic quadrilateral popping up there. Right? So we have a few things on the inside there. Now, check this. We also have a tangent and a chord. So that angle is equal to the angle in the alternate segment. All right? And then we also have, this is a radius. There's a tangent. So we have 90 degrees. And the same thing on the next side too. That's tangent, that's radius. So you have 90 degrees, 90 degrees. So we have lots of things popping up. And then we also know that the angle at center and this angle here are supplementary, right? Which means they add up to 180 degrees. So we could find that angle if we had to find it, right? Okay, let me see what they want. So the first angle they want is ACD. So ACD is that angle up in the corner there. Right? So we know that that angle is related to this angle here. Right? And then AED, let's take a look at AED. Where is AED? Oh, look, AED is here. And we talked about that just now. We know that these two angles are supplementary because of the work we did. Oh, okay, check it, right? Let me blank out some lines, right? Give me a second. Where my white? Right, so check it. If we blank out, we're gonna blank out a few things. Right, so blank out. Oh, no. Leave yourself. Stop that. Right. Right. Okay. No. What are you doing? Right. If we blank out this line here. Blank out this line. Oops, hold on 1 second. This line here. Right? And let's blank out that line there. Oops. This line here. And this line here. Okay. So let's zoom back in. Right. So check this, right? If you focus for a second on this tangent here, and you put in the radius here and here, right? What do we know about the angle between tangent and radius? So I have a 90 here and 90 here, right? But do we agree that the two pink and the two blue lines create a quadrilateral? And the sum of the interior angles of a quadrilateral is 360. So if two of those angles are already 90 and 90 is 180, right? So we have 180 degrees out of 360 accounted for, which means we have 180 remaining. And these two angles, therefore, would be 180 when they add them up. All right? This one now, let me see what's going on here. They want OAC. So OAC is this little angle right here. A high number? Yeah. Well, it couldn't be high. Because we know that, look, hold on, I'll give you a little hint here. Remember, we know that, just now, that has a piece to play with it, yes. Okay, right. This line is a what? Radius. That's a radius, which means that this triangle here in pink is what kind of triangle? And we could therefore find this angle here and this angle here, not so? Yeah. On top of which, we know that this angle here between the tangent and the chord is equal to the angle here in the alternate segment. So if we were to find the whole pink angle, and we take away the orange piece, we would be left with what it is they want us to find. Right. So again, the pink angle exists in a triangle, an isosceles triangle, where the two base angles are equal, not so? And do we not have the 114-degree angle at the top there? Right. And the last thing they want us to find is ABC. So ABC is this angle on top here. All right. So let me go back here. Sorry. What? Oh. Yeah. So they want us to find. We call that D. This is A. Sorry. That's B. This angle here was angle C. Right. So we have 4 angles to find there. Kem. Hey, Kem. You join it. You like it, and you share it. Thanks very much. I appreciate that very much. Which one? Hold on. Which part you doing? 1, 2, 3, or 4? Oh, okay. Part 3. Right. So is it? Yeah. What are we doing here? Sorry, what? This piece here will be 18. But we're looking for this piece here. Right, so 114 from 180 is 66. Check it. 180 minus 114. Okay, all right, I'll check all that after. I'll call back Jamaica as well. I'm not even sure if it's there, but yeah. Yeah, so 114 from 180 is 66. 66 divided by 2 is 33. And that's the whole angle here and here. And you'll subtract the 18 from that. Yeah, that's correct.
Right, that's not the way.
Yeah.
Oh yeah, 15. 57 plus 15.
Whichever headache, I don't know.
So it's 18 plus 72.
You can tie the head and squeeze it.
Oh yeah. 33. Oh yeah, sure. Wait, so I put that's 15. Wait, so that means that can't be 57. It can't be 57. It has to be because right. Because that's it'll be because it was 30. Oh no, not C, we talking about. You didn't add back this 18 outside, right?
No.
Oh no, it is 57. Yeah. It's not right. It's just a little time. Because what she did was she turned this into a 90 because this is not 90 minus 33 minus what he did was 90 minus look from here now. She did 90 minus 3. We had 1 to be sure. So I 90 and we had 18. So we should find this. Oh, I think sorry. I tried to 90 for everything one time now. That's my bad. Yeah, you have to.
That thing for me.
Run that by me one more time. I can't divide what?
57 degrees.
To get A, the angle of the center is double the angle of the circumference. But to get B, you have to subtract it from 180. But the pink angle in the center and the green angle externally are supplementary. They add up to 180. All right, so let's start putting together some solutions here, right? So I'm going to wait. I should have copied this page. All right, I'll leave it. All right, hold on. It's A I want. Okay. So again, to help see things a bit more clearly, I'm going to kind of disappear some lines here, right? So give me a second. No. Be yourself. All right. All right. Right. So I'm actually just gonna disappear like practically everything else. No, not that side. That side is necessary. What are we doing? Let me just clear it out. In the club, we all fam. What? Page, where you know that from? Because that to me is a real old thing. Right. So here we could see that angle A would be 114 divided by 2 because the angle at center is double the angle at the circumference, right? Let's put that. You seen it now? Right? All good. The good thing about taking the scenic route is you find other things. And when you find other things, you can use them later on. People just say all kind of weird things, yes? I tell them the circumference. You see what I mean, circumference? I'm like, no, circumference. So, well, it could have a misconference. I'm like, no. What was that uns? They come for what? Like, oh, okay, all right, so that's part A. Part B now. Part B is AED, which is the green angle on the outside there, right? So again, as we said, we kind of blank out some lines there. The two blue radii and the two pink tangents form a quadrilateral. The sum of the interior angles of a quadrilateral is 360 degrees. So the two angles, hold on, I'll blank out, I'll reblank it. Right, cool. Right, so this is a 90-degree angle here. That's a 90-degree angle there. Right, so we have two 90-degree angles which together sum to 180, which means the remaining two angles, the 114 and the green, had to be 180 as well. So to find the green angle, we could simply, subtract 114 from 180. which is 66. Right? The only thing I could tell you, they didn't give us an articulation of this. You could just say that AOD and AED are supplementary. What is what, sorry? Oh. Hey, Mike, how you doing? Good to see you. Right. Let's take a look at this part here. So in this part, they want the blue piece. So let me see if I can just give me 1 sec, right? Right. So they want that blue. They want that blue section there, right? So, like I was saying, this angle here, right? So those two angles, right, are 18 degrees because the angle between tangent and chord, right? Because this is a tangent here and this is a chord here. That angle is equal to the angle in the alternate segment, right? Which is this angle across here with the kind of double orange strokes, right? And then, like we were saying, what we could do is we could actually find the whole angle here. Because, again, in that triangle, the OAD triangle, the pink triangle, it's isosceles. Because these two sides, this side here and this side here, are radii in the same circle. And in any given circle, all radii are equal in length. So if you build a triangle using those two radii and the chord AD, you'll have an isosceles triangle, which means that this angle here and this angle here are equal. So we could do 180 minus 114 and then divide that by 2. Right? So that's going to give us 66 degrees. When we divide it by 2, we're going to get 33 degrees. And then we could simply subtract the 18-degree portion and get 15 degrees for the answer there. Right? So that one had a couple of layers there. You had to know what, sorry? 15, yeah? For the blue, yeah, the blue angle. Well, I mean, to me, the only way you can really find that angle is to subtract the 18 from the whole angle here. I'm not sure how else you would actually find that angle. Okay. Somehow, well, once your logic is sound, you should be okay. 180 minus 114 will give us 66. Okay. And then you take away what from that? 18 here. Right? What? And what? What here? 36 from 66 is 30, and then 30 divided by 2 is 15. I know how you get 18, and yeah, I know you get 18. Right. So OAC is, we said 33 minus 18, which is 15 degrees, right? So we have layers here. So the 18 is angle between tangent and chord. And the 33 is, well, as 180 minus the 114 divided by 2. And you have layers here too, right? So you have, I think, 3 rules here. Oh, no, 2. You have the sum of the angles in a triangle is 180 degrees, and then the base angles of an isosceles triangle are equal. Right? So I won't worry to write and all of that stuff. Okay. We have one more piece here, which is ABC, which is the orange angle here. Right, so we said that that angle, right, we actually have a cyclic quadrilateral here. Yo. What are we going to do? I don't know what to tell you. Yeah, same question. Right, so we've seen the cyclic quadrilateral, and if we could actually find out this angle here, and we actually could, because we know that this piece here is 33, and we know that this is 90, because angle between tangent and radius is 90 degrees, right? So that's 90, and this piece here is 66. Sorry, let me say 18. 90 minus 18 is 72 degrees. All right, so that piece there is 72 degrees. So we could add 72 and 33 and get 105. And then 105 from 180 will give us 75, yeah? Right, I'm going to recap that. I'll go over it again. 33 plus 75. Right. Not 72, you mean? Yeah. Yeah, 72, yeah. Right, so like we were saying, we have a cyclic quadrilateral here. And the rule is that the opposite angles of a cyclic chord are equal. So the orange and the purple, sorry, they are supplementary. No, they're supplementary. Sorry, they're supplementary, right? So if we add the orange and the purple, we get 180. Now, we could find the purple, right? Because we know that we got one piece of it in the previous part of the question. That was 33 degrees. That was one of the angles in the isosceles triangle. And then we also had that this is a radius, and there's a tangent down here, and the angle here is 90 degrees, right? So this whole angle here is 90 degrees, and we have one portion of it being 18 degrees. So to find the remaining portion, we could subtract 18 from 90 and get 72 degrees. 72 plus 33 is 105. 105 from 180 will give us 75 degrees. Yeah. Yeah. So ABC is equal to 180 minus 33 plus 72. That's 105, and that is 75 degrees. So 180 minus, that is because opposite angles of a cyclic quadrilateral are supplementary. Right, and the 72, we had explained that one at least a little bit. Right, that one was 90 degrees minus the 18. Right, and the 90 was because angle between tangent and radius. Whew, yeah, that one was a little long. All right, in class, people, are we okay with all four parts of that one, or is there any one part I'm going to go over? Or more than one part? Yeah. Yeah, go ahead.
Okay, so you know you can see when you did the angle at center is twice the angle at circumference.
Yeah, okay.
How come that didn't work out for B?
Because you'd have to, hold on, you'd have to have a line going like this. Yeah.
Like usually, like angles at the angles when angles at the circumference and angles in the center, right? Does it primarily have to count with the RL rule, or is it like in general?
Right. So it only works in these situations. Arrowhead. So basically what's happening is you have these two radii and you have each radii has a chord coming from it and those two chords meet at a common point. Right? And you could rotate those points anywhere.
This line would have, no, this line would have to be, yeah, it have to, yeah, it have to be B to B. Yeah, that makes sense. Alright, Chris.
Second part. This part here. This one on this angle on the outside here. Yeah, because 114 and this angle are supplementary. They add up to 180 degrees. So if 114 plus an angle is 180, you could subtract 114 from 180 and find the missing angle, which would be 66. Yeah, Google Meet, I figured it all, yeah? I just kind of got caught up in explaining and doing the question. Sorry about that. But yeah, if you guys are good with the full question, give me a Genie chat. If, however, you need me to go over part A, B, C, or D, you can let me know, It's not a problem. Right? Let me know. Right? We have other things to do, and it's the last day we spend on circle geometry. But if you have questions, please do ask them, What? Oh, yeah. You know this already. Okay. Mama Sheila, what vibes? Right. Okay. All right. So, guys, we going on to 2017 May now. So this one's a little easier. Yeah, good. That's why practicing as many questions as possible and getting them corrected is very important. All right, so let's take a little quick look here. The only one, two things here, so I could probably fit that in the same diagram. All right, so P, Q, R, and S are 4 points on the circumference of the circle shown below. Angle QRS is 58 degrees. So they only give us one angle in the whole diagram. All right. Queenie, hey K, what vibes? Thanks for sharing your life. Thanks for following. Appreciate it very much. All right. You guys have a good evening, yeah? Honestly, I'm not running you. Just wishing you well. Okay. Using the geometrical properties of a circle to give reasons for each step of your answer, determine the measure of SPQ. So SPQ is this angle here, and OQS is this angle here. Now, O is the center of the circle, right? So we know that OS and OQ would be what? They would be radii, which would be equal in length. Okay, right. So that's all I'll give you for now before I give away the whole question again. But there's one more thing. If you blank out this here, are we seeing the cyclic quadrilateral?
Yeah.
Right.
The opposite.
No. So with the cyclic quad, all the vertices have to touch the circumference. The O is the center of the circle.
It's just large, right? It's just large. I know I can't remember how to show. Yeah, that one was like. Never mind. I know it was different. Yeah. Cos E minus B something like that.
Hey, more people jumping in, boy. Privately fee. Angie Das, Black FX, Sticky Nicky, and Davey. Alright.
I hate that, but I hate
Off of a what? Of a CF curve? We could. Usually when we hit past papers and we're doing topics like that, when I say when we hit that topic, we'll do it, yeah. Alright. Cool. Off of Jan. Right, so we're supposed to organize Jan sessions, eh? That's- Right. So, like I said, if you blank out this triangle in the middle here, we see in the cyclic quadrilateral, yeah? And the opposite angles are supplementary, which means that to find the pink angle, all we have to do is subtract 58 from 180 degrees, right? I won't bother to write the rule. So that's 122. Okay, now to find the green angle, what we could do is we could actually blank out, let me tell you, it is what? 68, 34. Right, if you blank out that item there, and you blank out this for a second, are we seeing the arrowhead? And with the arrowhead, we could find the interior angle there. Oh, I think it's an obtuse angle. Right, so you can find this angle here. That's 116 because the angle at center is double the angle at the circumference. And then if you reintroduce this line, we have an isosceles triangle, right? Because the two lines with the blue strokes, those are radii, right? So you could subtract 116 from 180 and then divide by 2. 180 minus 116 over 2. That's 64 over 2, which is equal to, you said it correctly, 32 degrees, yeah. Yeah, so that one was a little more manageable than the previous one. Previous one was a good run for your money. This one had a couple layers in the second part of the question. That's cool. Hey Jason, all right. Right. We okay with this one? Any questions? Anybody? Anything? Right. Google Meet, just give me a quick G if you're good with what's on the screen, please and thanks. Hey Tommy, go ahead. Good to see you. We renewed the insurance with the car today, so it should be. I had to print out the certificate, so you got to pass it. Or I gotta meet you and give it to you somewhere somehow. So remember to do that, right? Print out the insurance certificate. Okay, going again. 2017 Jan. This one has 3. Right. Diagram below not drawn a scale shows a circle with center O. So O is the center, people. O is the center of the circle. The vertices H, J, K, and L of a quadrilateral lie on the circumference of the circle, right? So H, J, K, and L lie on the circumference. PKM is a straight line, which is a tangent. The measure of HJL is 20 degrees and JKH is 50 degrees. They want us to find. Oh, let me see if I could copy this. Yeah. So OJK is isosceles. That is correct because this is a radius and that's a radius. Subtract from 180, yeah. So the first angle, they want HKL. HKL is this angle here. We'll call that angle A. Sorry. Sorry, say that again. 80, yeah. JOK is this angle here. We'll call that angle B. I agree with that, yeah, that's 80. And then JHK. JHK is this angle here. We'll call that C. That one easier than you think. Yep. That's correct. Right, so I'll give you guys a few minutes to contemplate. In about a minute, I'll give you a hint to find A. B is pretty easy to find. C is pretty easy to find once you remember that. All right. So O is the what of the circle again? O is the. And if you have a line passing through the center, a straight line, what do you call that? Diameter, right? Oh, hold on. That orange line is showing up at all. Wow. Let's I don't know about isosceles, but I know that if you close it up here, you have a right angle triangle. And you also have a triangle here as well. Yeah? Is each 90 degrees? That's that interesting. Well, you said A is 40, but I think A is 40.
Because if that radius is coming down there, that's 90 degrees, 90 minus 50, 40, to find that small segment there.
So this angle here be 90, I agree with that. And this angle here be 90, I agree with that. I don't know that this angle is 90.
Oh, yeah, you're right.
Hold on. Hold on, that's now. Where are you trying to find angle A? Hold on, sorry, which angle? JHK? Yeah. No, sorry, I thought you said angle A is 40 after I drew any little pink things, yeah? Sorry, say again? Hold on, Hanifa goes to your school, right? All your maths exam done, right?
Or simply, if this is 80, find the remaining of this, 360 minus 80.
It was last week?
If you found that, you can be able to find. No.
right. So for Rick, love this program. Hey, thanks very much, buddy. I appreciate that. Oh, Eddie. Right, sorry. So angle A is 20 degrees because angles in the same segment standing on the same arc are equal, right? Cool. That's what I'm showing you. So going forward, you know how to look fit. Right, JOK. Right, so again, what we were saying here is that what? Those two are radii, which means they're equal, which means that this angle across here is also 50 degrees. So to find B, all we have to do is add up 50 and 50 and subtract from 180. So 50 and 50 is 100. 100 from 180 is equal to 80 degrees.
Oh, sir, I'm crazy.
Uh-huh.
That means the angle next to the 50 on the right is that's supposed to be 40.
Next to the 50. Yeah, this angle is 40.
So I confused. That's my one. That's what I thought.
No problems. That's all right. This happened. Now that means that this angle across here is 40 as well.
That means yeah. So that means if we find.
And that means that this angle across here is 40 as well.
Wait.
So that's GHK. Yeah. Yeah, because look, if you look at it, check this, right? This side here is a chord, not so?
Yeah.
And this line here is a tangent. And if you focus on this triangle here, the angle between tangent and chord is equal to the angle in the alternate segment. So that's a way easier way to find it. I mean, you could always say that this angle here is 90. So 90 plus 50 is 140. That's fine. That's perfectly valid as well because that angle is 90 because angle in a semicircle. That's fine.
We found 40 on that one side. We have to find the entire angle.
No, JHK goes from here to here to here.
Oh, I didn't see that.
Yeah.
Okay, ours is 40 then.
Yeah.
That makes sense. Yeah. That makes sense. No, I just unlocked the entire thing.
Right. So you would have to make sure and see that that this is a radius, this is a tangent, and the angle between them is 90 degrees, right? Which means that this angle on the outside here is 40, not so?
Yeah.
And this line here is a chord. And the angle between tangent and chord is equal to the angle in the alternate segment. So this is 40 degrees. Oh yeah. It nothing wrong with being explicit in the explanations. All right, so folks, I printed out 3 more. So what I'll do, I'll just give them out. You all could always try them because we don't have time. Had I started on time, we would have definitely finished these 3. Sorry about that. But, these two 2016 questions look like real food here. The 2015 not so bad.
have no choice. You understand? And that's right. Yeah, I was like,
Right, so, people skip that learn, but I didn't say. You see, we did this in school and didn't understand, but now I do thank you. Yeah. Hey, soul for Rick. I'm glad to hear, understand it now. I'm very happy to hear that. That's why I do what I do, because I know sometimes things in school don't always click, you know? Right, so what I'll do, Google Meet is I'll send you guys those 3 questions. I can always try them and send them back. Anyhow, folks, that's it for circle geometry. Starting next week, we're in December. As of Sunday, we're in December. So December, January, February, March, April. That's it. You have one hand worth of months until exams. Right? Boy, anyhow, next week we start in trigs from scratch. So if you never understood trigonometry, I will endeavor to make sure you understand it from a relatively fundamental level. Right? Yeah. Yes. Right. So just to remind you, for those who may have forgotten, hey, could you just open up there? Right. Yo. It's red. Yeah. So next week, Monday and Wednesday, we on as normal. The next 2 weeks after that, we have class Monday, Wednesday, Friday from 1 to 3 for the maths people. Right? POA is 10 to 12. Right? And well, I have my maths people as per usual. I'll be 4 to 6 because I'll probably have to go for my son, which takes about an hour. All right? Next week, normal. The 2 weeks after that, Monday, Wednesday, Friday, 1 to 3. Just like in summer. Right? Because all you're home from school. So we had to wait till 6:30 in the evening. You could. Yeah. Huh? Monday, Wednesday, Friday. Yeah, well, do your thing. Alright. Okay, yeah, man, on. Alright, so Google Meet will go on now. So, of course, if you have any questions, please feel free to let me know. Alright, so I'll see you guys next week. Later. No.